Hello, welcome back. So today in this video, let us understand what is Cosmos DB partitioning. What is the concept of partitioning in Cosmos DB? As you have seen in the previous videos, we have seen the introductory videos of Cosmos DB and the different APIs that Cosmos DB provides, and also we have seen the how to create a Cosmos DB account and the details in the previous demo. So please, I recommend you to watch the previous videos. And also, if you are in learning path about it and haven't subscribed for this channel, please do like and subscribe. And also don't forget to press bell button for instant notification. So let's get started. So understanding Cosmos DB partitioning is of two things. One is of a logical partitioning and physical partitioning, and we will discuss that in detail. As you know, in Cosmos DB, whenever you create an account and a Cosmos DB account, you'll be having a Cosmos DB created inside account, that is Cosmos database. So inside a database, you need to create a container. So container is like similar to the tables that we are talking about in the RDBMS world. So this container will be holding your actual data in terms of maybe a JSON, usually in the JSON format, which is a document DB type. So whenever you, as you see, if you are very familiar with database systems, right, you are having a partitioning concept there also. So basically what is partitioning and why we define that partitioning is, it is especially for the performance related things to enhance the performance, as we are storing the uh, data which are related to each other in a single slice basically, so that whenever you are reading or writing, the performance will be more faster. So that is the whole simple intention of partition. So similarly, exactly similarly, we are doing the same thing here in the Cosmos DB. What happens is we will define a partition key. So partition key can be any one of the column that you are using in your data. So suppose you are having a employee table or customer table. Okay, so that customer will be having first name, last name, country, pin code, anything, right? So you can use any of these columns as a partition key. But please note, it is not like you can just randomly select partition key. So there is a bit of analysis that you need to do to choose the proper partition key. So which be eligible for the partition key. So that comes with the proper analysis. So suppose here I've taken the example where I've taken the partition key as a country. So whenever you are selecting a partition key as a country, when you're creating a container, what happens is whenever you start inserting the data which you insert for the country UK will go into a one logical partitioning, and the data which you put for the India will go into another logical partitioning. So logical means it is just uh, behind the scenes. Cosmos DB is creating this logical partitioning, but you cannot see this logical partitioning, or you cannot also see the physical partitioning. Everything will happen in the background. But this is the actual process. So why we are discussing this? If you understand this process which is happening in the background, so it helps choose the proper partitioning key and understand what's happening behind, and we can utilize complete power of partitions. So as you can see here, the whenever you start putting the data, it will be logically clubbed into a different logical partitions. So after that, what happens is there will be physical partition. Physical partitions are nothing but suppose you have a Cosmos DB account, and Cosmos DB account, yeah, as you know, it is a globally distributed one, and it's fully managed. Fully managed in the sense you don't create a nodes. Basically, if you're having a one node, right, and if you are start storing more amount of data, right, it will create one more node. So like that, it will create a number of nodes. So it might create a number of nodes. So and that is actually what we call as a distributed computing. So Cosmos DB in background, it will perform the distributed computing by using n number of nodes, right? So nodes are nothing but this might be one machine, it might be another machine, right? Or this might be one disk, or this might be another disk. So basically these are physically not the same entity. Physically these are separate entities. So as you can see, the logically clubbed partitions are put into one physical partition. This is partition 1, you can consider physical partition, and this logical partition, the whole country US chunk, is dumped into a physical partition 2. So if you can see here how this is divided, why 3 are going into this and why only 1 is going to this. This is quite a simple calculation. If you see, these are small chunks of data, so these are clubbed into one and put into a one physical partitioning. But internally these are separate logical partitions, but they are going into one single physical partitions. So this is huge partition, right? So we are trying to put it in one single physical partition. Okay. So and this happens dynamically. So tomorrow there might be case the data of UK grows very more larger than US, right? So So in that case, the partition might get exchanged. So this happened dynamically basically. So, but as a user, you don't care about this, what is happening. I mean, so which data is stored in which partitioning, partitions or logical partition or physical partition. We don't need to care about it. So hope this is clear, right? So as you can see now, quick definition of these two, right? So logical partition is nothing but items in a container are divided into distinct groups or basically distinct groups or sets based on the partition key. So whatever partition key you are deciding, so that based on that, your data will be distinguished based on the distinct group or subset. So these are group or subset you can call. So based on this partition, and they will be called as a logical partition. And coming to the physical partitioning, one or more logical partitions can be pushed or saved in a single physical partition. Simple as that. So I don't want to confuse more about this. I want to keep it very simple. So this makes it clear. But please note that it cannot happen like you have a data. So I'll just show you the example. You cannot have the data of country India going into this partition also, partition 1, and going into the another partition, which is partition 2. This is not possible. Definitely this is not possible. So all the logical partition data should always be stored in a physical partition, because you need to understand the intention here when you're reading or writing the data from this for this particular partition data. So the intention is to have the better performance. So if it is stored in two different physical partitions, so you need to touch both the partitions here. So that will be a performance issue. So that is the whole intention of this. So hope this slide is clear. So let's move to the last slide, which are having a couple of points to discuss here. So this might seem little theoretical, but definitely these are very practical things when you start working on Cosmos DB. So as you can see here, there are a few points to recap. So as you have seen, each DB has multiple containers. Each Cosmos database will have multiple containers, and each container data is logically grouped, and that we call it as a logical partition. So this is very important. This happens based on the partition key. So one or more logical partition data will be stored in different single physical partition, that is physical partition. So this process, as we discussed, it happens dynamically and changes as data volume grows, right, or shrinks in logical partitioning. And so we have more, we can have more physical partition tomorrow as the data size grows, right? So either we have a data volume growth or physical partitioning growth, right? In any cases, this will the data how we are storing, right? So it might change. The partition might exchange, or tomorrow there might be one more physical partition, and that data might be shifting to another physical partition. So this will be keep on going based on the data volume and the number of physical servers or locations or hard disks that you have. And the entire process happens in a background. So this entire physical logical partitioning will be happening in the background of and we will not understand we will not know as a user what's happening in the behind the scene in detail, but this is what happens as a summary at a high level. And next is whole process of partitioning is to have optimal performance. So the whole purpose, right? So that is to have a optimal performance. So this is why we are the Cosmos DB is doing all this uh, behind the scenes. And partition key cannot be changed once defined. So this is very important. Okay. So if you have already worked in Cosmos DB, then you clearly understand this, because once you create a container with a particular partition key, you never cannot change it. You cannot change it. So you have only one option, is to take a backup of data and recreate the Cosmos DB with a new partition key. And imagine in the production kind of scenarios that might not be affordable case to do. So it is very important to choose the partition key based on the proper data analysis. Suppose if you are having if you're creating a container, there might be a number of columns, right? So which column should be a partition key? So that takes a lot of analysis when you are actually working in the real-time production use cases, because that decides your Cosmos DB performance. And if you're choosing a wrong partition key, you are on the toss. So that's gone. So please be careful. So I will not go in detail what exactly to consider when you are going to do a proper data analysis, but at a high level, you can consider like so you cannot choose a timestamp, or you cannot choose the ID. If you're choosing an ID as a partition key, right? So then you can imagine how many partitions it will be creating. Lot of partition. So definitely you should avoid lot of partition to be created. So you should keep the partition to as minimal as possible. So usually the partition will be like country, location based, or like a particular domain based, or particular kind of account based. So that kind of columns or attributes are eligible for a partition to act as a partition key. So that's very important. And the last point, if you can see, cannot afford to have too many partitions. That's what we are discussing. Also on the other side, also we cannot have many logical partition grouped into single partition. So we need to strike a balance based on the data analysis. So the key is data analysis. So analyzing the data and coming up with a proper partition key can make a lot of difference. So that's the whole trick that we should be doing here. So hope this was useful, and you were able to understand the logical partitioning and physical partitioning and the difference between this, and how these are working behind the scene, and how we can control things. So what we can control is, only thing we can control is this defining the partition key. The rest all will be behind the scenes. And choosing the partition key needs a lot of data analysis and the work, so that you need to understand the data properly, how you need to spread the data across different logical partitioning. So that's about it, and thanks for watching.